year 2038. This is a crewed interplanetary transfer vehicle bound for Mars, and it will cruise at 0.8% the speed of light on its one-year journey to the red planet mankind left Earth for the first time to walk on another world. How will the crew survive the deep space transit? What systems keep them alive on the way? How will they land on Mars and return home safely? What happens when they touch down on the rust-colored plains of Utopia Planitia and spend 30 sols exploring, living, working, discovering how will they launch themselves back off the Martian surface and rendezvous with the return vehicle orbiting above? What challenges will they face in the thin, chilly atmosphere of Mars and the void beyond? And how will their mission shape humanity's future on the red planet? The mission begins with the launch of the Ares IX stack from high Earth orbit. The interplanetary transfer vehicle separates from its upper stage and unfolds its radiators and sensor arrays beneath the glow of the distant sun. Nuclear thermal propulsion core ignites, generating thrust by heating hydrogen propellant to 10,000 kelvins. The acceleration is gentle but continuous, pushing the ship onto a heliocentric trajectory that intercepts Mars. The crew module is nestled within the protective shadow of the habitat ring, shielded by layers of water and polyethylene to block interstellar radiation. Inside the habitat ring, the crew awakens from long-duration stasis. The life support systems hum as fresh oxygen is circulated, and carbon dioxide scrubbed by regenerative sorbent beds. Arrays of LED grow lights illuminate stacked trays of leafy greens and tubers in the hydroponic farm. The first harvest of lettuce, kale, and potatoes is stowed in cold lockers, ready to supplement freeze-dried rations. The medical bay comes online, and the crew undergoes health checks, bone density scans, muscle strength tests, vestibular system calibration to assess the effects of microgravity and prepare for the partial gravity they will soon encounter. Navigational sensors lock onto Mars. As the transfer vehicle performs its mid-course correction burns, the trajectory is fine-tuned to arrive at Mars orbit with a periapsis of 300 kilometers over the northern lowlands. Crew gathers in the observation dome to watch the great red globe grow beneath them. The swirling polar caps retreat and advance in seasonal patterns. The basaltic highlands and ancient river valleys come into focus, a tapestry of geological history unfolding in crimson and ochre. The descent vehicle detaches from the transfer ship and fires its braking thrusters. The heat shield endures temperatures of thousands of kelvins as it plummets through the tenuous Martian atmosphere. The parachute deploys, billowing against the rarefied air and slowing the vehicle to subsonic speed. The retro rockets ignite in a pulsed sequence, hovering the lander over its designated touchdown zone in Utopia Planitia. The landing legs extend, each tipped with crushable honeycomb struts that absorb the final impact. The dust cloud settles and the crew feels the gentle jolt as the lander touches down. This is humanity's first crew on Mars for a short-duration sortie. The lander cabin door opens and the crew dons their suits. Sealed and pressurized, they step onto oxygen-enriched ground, their boot prints pressing into regolith that has never felt a human tread before. The horizon is flat and broad, the sky tinged butterscotch beneath the weak sunlight. The landscape is littered with rocks shaped by wind and ancient floods. Distant ridges trace the margins of buried basins. The habitat module unfolds like a flower and locks into place behind the lander. The inner membrane inflates, creating a volume of living space where gravity is set to 0.38 g to simulate Martian surface conditions. The floors, walls, and ceilings are lined with insulating blankets and micrometeoroid shielding. The crew powers up the environmental control and life support system. Reversible fuel cells generate water and oxygen. Colorado dye scrubbers recycle cabin air, and the greenhouse modules extend translucent panels to admit sunlight for the crops. The mission timeline for 30 sols begins with site surveys and the erection of the communications mast. The high-gain antenna swings into alignment with the orbiting relay satellite. The data stream is continuous. Panoramic images of dunes, spectral readings of mineral outcrops, seismic tremor monitoring from the lander's hammer probes. The science team directs the rover, Cydonia 2, to deploy the ground-penetrating radar unit and drill a 1-meter core to sample icy layer deposits beneath the surface. The crew suits trek across the plane to set up the in-situ resource utilization unit. Its reactor processes Martian regolith through hydrogen reduction, extracting oxygen for breathing and water for the farm. The spent basaltic fines are stockpiled as construction aggregate for future crews. The ISRU unit also generates methane fuel via Sabatier synthesis, combining CO2s from the cabin exhaust with hydrogen recycled from water electrolysis. The methane is piped to insulated tanks for the return ascent stage. Daily operations include soil chemistry assays, ultraviolet flux measurements, radiation dosimetry, and geology transects to catalog sedimentary structures left behind by ancient rivers and lakes. The crew collects rock samples from a nearby Eskers Ridge, storing them in hermetic tubes for return to Earth. The medical officer conducts ultrasound scans on crew members' muscles and heart tissue to monitor adaptation to Martian gravity. Psychological well-being is maintained through virtual reality uplinks to mission control on Earth and family messages delayed by the two-way light speed lag. The habitat's common area hosts communal meals of rehydrated stews and homegrown spinach salads under the soft glow of circadian cycle lighting. The software simulates Earth's sky color and cloud cover to ease homesickness. Radiation shelters are constructed beneath the regolith berm surrounding the habitat. Each shelter is an inflatable polyethylene tarp covered by a meter of packed soil. The crew retreats during solar particle events detected by the onboard radiation monitors and relayed by the orbiting observatory. Mid-mission, the rover expedition ventures to a collapsed lava tube near the base of Elysium Mons. The overhead ceiling has given way, revealing a cavernous tunnel that could serve as a natural radiation shield for future habitats. The crew deploys LiDAR scanners and microbial samplers to analyze the stability of the structure and search for signs of extant life in subsurface brine channels. The agriculture team harvests the first batch of tomatoes and peppers from the hydroponics array. They measure growth rates and nutrient content, refining the fertilizer mix to boost yields. The aromatic warmth of tomato vines fills the cabin and lifts spirits. The first seed harvest is stored in vacuum-sealed banks for redundancy. Structural engineers test 3D printing of Martian concrete by combining regolith fines with polymer binder to fabricate replacement panels for the habitat floor. The tensile strength tests exceed 100 megapascals, demonstrating viability for constructing landing pads and radiation shelters for future missions. On Sol 28, the ascent stage is fueled with ISRU-generated methane and liquid oxygen. The descent stage is jettisoned after packing essential samples and equipment. The crew holds a brief ceremony by the central greenhouse, sealing a time capsule with letters, data drives, and regolith samples to be discovered by later explorers. The ascent stage ignites its engines in a steady throttle profile to accelerate the crew module to orbital velocity around Mars. The centrifugal forces press the crew into their seats as the vehicle arcs upward, passing through the atmosphere. Once more, the dust-blooded clouds swirl below. The rendezvous beacon locks onto the transfer vehicle in a polar orbit, 150 kilometers above the surface. The docking maneuver is automated, but the pilot stands ready to take manual control. If needed, the two vehicles connect with a prosodish shutter and soft clicks. As the latches engage, the crew transfers back into the main habitat ring with their experiments, rock cores, and agricultural yields. The return trajectory burn is performed by the nuclear thermal core, bending the path away from Mars and back to the inner solar system. The communications array pivots to re-establish direct links to Earth orbiters and ground stations. The crew settles in for the transit back, reactivating the hydroponic farm and running new crop growth trials to test long-duration viability. During the return cruise, the crew synthesizes oxygen and water from stored electrolyzed tanks, recycling metabolic waste through bioreactors that feed algae beds and nitrifying filters. The algae produce organic biomass for protein supplements while stabilizing cabin air composition. Navigation officers conduct stellar navigation by sighting multiple quasars through the observation dome to calibrate inertial guidance sensors. The vehicle passes by the asteroid belt in Jupiter's orbit, the gas giant's swirling bands seen only as faint stripes through the dome windows. The medical doctor administers bone-stimulating ultrasound and resistive exercise regimens to prevent demineralization and muscle atrophy. The psychology officer leads group sessions in zero-G spatial games that require coordination and trust to maintain cohesion. As Earth's blue marble grows in the viewport, the crew prepares for Earth capture operations. The transfer vehicle performs a flyby of Venus's orbit to use a gravity assist. Trimming Delta V requirements for the final approach, the radiation monitors record a spike in cosmic rays near Jupiter's magnetosphere, data critical for designing deep space habitats. The Earth re-entry capsule detaches and orients its heat shield toward the oncoming atmosphere. The ablative tiles endure temperatures peaking at 2000 kelvins as plasma flows around the vehicle. The parachute system deploys at supersonic speed in the thicker layers of atmosphere, slowing the capsule for splashdown in the Pacific Ocean. Recovery forces hover in helicopters overhead, tracking the capsule by radio beacons. The crew emerges into sunlight, blinking against the glare, their suits coated in char marks from re-entry. The hatch opens, and the first crew member steps onto the recovery raft, supported by medical teams and buoyant floats. Samples and data drives are quickly transferred to the command ship. The rock cores are secured in dry ice containers, ready for shipment to laboratories around the world. The hydroponic produce is harvested for nutritional analysis and public display, proof that off-world farming can sustain explorers. In the debriefing pavilion, the crew describes the surface conditions, from the biting cold of shaded hollows to the soft wind that kicks up dust devils across the plains. The engineers review habitat performance, noting slight shifts in the regolith berm due to thermal cycling and advising design tweaks for next missions. The mission is declared a success. The first human boots on Mars, the demonstration of in-situ resource utilization for propellant and life support, the first full-cycle agricultural harvest off Earth and back again. An echo of humanity's spirit of exploration now extends beyond the cradle of Earth. What will the lessons of 30 souls on Mars mean for the future of exploration? What new discoveries lie under the rusty soil? What challenges remain before a permanent outpost can be built? And what stories will the next explorers bring? Back to Earth. This journey has answered many questions, but opened countless more, and the adventure of human exploration continues onward, beyond the rust-red horizon of Mars. In the next episode, we will see how space around Earth turns into a busy place for travel and research in the year 2040.